So now we'll do the present value of a deferred annuity. This is brief exercise 614, so you have a reference to go by. Amy wants to create a fund today. She wants to withdraw $25,000 per year for 8 years. That would be nice. With the first withdrawal not to happen until 5 years from today. 8% is her interest rate. How much should she invest today? So we could go through our little thought process here. Do we need to know the present or the future? How much should she invest today? We need to know the present. Is it a single sum or an annuity? Well, she's going to have 8 equal withdrawals of $25,000, so that sounds like an annuity to me. And we're going to treat this as an ordinary annuity, and it is deferred. Okay, because it doesn't start right away. It starts at the end of year 4. It starts at year 5. Okay, so now we have to figure out the total number of periods. And here, this is where something like this comes in handy on these. You have to figure out the N equals, we know that the I equals 8%. So altogether, you're going to have 4 years that are deferred. Starting with the 5th year, they're going to have 8 equal payments. So when I did this, I started with 5 and I did the dots first. I went, okay, we're going to have 1, 2, 3, 4, 5, 6, 7, 8 payments, and that gets us up to 12. It works for me. Okay, so the total we have the total N is 12. Okay, so there's 12 periods altogether, but minus 4 periods are deferred. Okay, so what we're going to do here, just don't want to get too confusing here. What we have to do is we're going to look for the present value of an ordinary annuity, and we're going to take the entire period of 12. N equals 12 and 8, whoops, 8 wasn't so good, 8%. Okay, so we're going to take that. So that would be the total period of 12. And then because we're dealing with the present value and not the future, we have to go minus the deferred period. So we take the present value of an ordinary annuity of the deferred period, 4 at 8%. So this is less the deferred period. And that would give us the factor to use. Okay, so if we put in some numbers here, we would go to the present value of an ordinary annuity table, N equals 12, 8%, and we would get 7.53608. And the deferred period, we would go to the same table, except 4 periods, 8%, and we would get 3.31213. We subtract those, and that gives us the appropriate factor of 4.22395. We would multiply that times the 25,000 that she wants, and we would get the amount she has to deposit today of 105,599. So that would be our solution to this. So when you're dealing with the present value of a deferred annuity, you have to map out the problem so it makes sense. You get the factor for the total period, less the factor for the deferred period. That gives you the factor to use, and then you solve it like you would other problems. So that is a deferred annuity, the present value.